Problem 1.5 says that sketch and label the even and odd components of the signals shown in figure 1 to 4. And figure 1 to 4 is right here. And we are going to work on figure 1 to 4a to start with. And as a solution, we are referred to equation 1, 5 and 1, 6. And equation 1, 5, I have rewritten it here. This is the one that defines an even signal in relation to its original signal. And figure 1, equation 1, 6 is the one that defines the odd signal, again in relation to its original signal x of t. Therefore, the first step for us will of course be to express this equation in mathematical form. And we can simply see that the y-intercept is 0, or rather where this line is crossing the y-axis. And our y-axis, of course, is x of t. This is our x-axis. And therefore, if you are to look for the gradient, you always remember that the equation always, a linear equation always takes this form, where this is the gradient, this is the x-intercept, and this is the y-intercept. Of course, this is the x variable. And this is the function that we are looking for. So in this case, we can see that the gradient m is given by change in y, which is 4, over change in x, which is 5. Therefore, we get an equation 4 over 5 t. And that equation is varied between 0, t is less than or greater than or equals to 0, and less than or equals to 5. Therefore, that is how we come up with this section. And it is 0 everywhere else. So you can see that a function y x of t is 0 anywhere else. That is how we define this. Therefore, from that point, knowing that we are going to require a negative of minus t or x of negative t, we just replace everywhere we have t with a negative. We have negative 4 over 5 of t, and negative t comes into our range. When you modify this, it becomes x of negative t will be minus 4 over 5t, and as we have done before, multiply by the negative in this inequality, and this changes such that for those who have not known that, it will become t will be bigger than negative 5. If you can see that t is still bigger than negative 5, you express it in this format. So we have done that for that, and therefore we are saying that the even function will be as the half sum of the two. So we just now express the half of the sum. Of course, it will mean that our gradient was 4 over 5, divided by 2 becomes 2 over 5. Therefore, for the first range will be that. When you add the other range, it will be expressed as that. So there are two different ranges and 0 elsewhere. And therefore, if we are to plot this on a graph, we will see that it will follow a smaller gradient than before. So you can see that the gradient now will be half of this. So it will be somehow like that, and the other side will come something like that. So that is illustrated on figure 125a, and this is the even component, just as we have found out. So if you are now to do the odd component, you do the same thing, except the minusing. You would minus the x of t, as we have seen at this definition. So we minus the negative function of t, and therefore it will change from being negative to being a positive. That's why you can see that positive, and then, but this will remain as it is. So now if you are to draw this, this will remain as it was before, but now drawing this function, it will mean that when t is equals to, for instance, 5, for t, when t is less than 5, negative 5, then you can put negative 5 here. You can see that this will be negative 2. So the maximum point or the minimum point will be negative 2 when you cancel this and this. So negative 2, you can see that you are going to the negative side, and therefore that is why you can see here that at negative 5 we have negative 2. So this is clearly an odd function of a function of x of t, and this is the inverse function of a function x of t. And similarly, we can express either of these. Just like the most important thing is to be able to express this function in a mathematical expression, and therefore we just replace respectively t with negative t when you want to find this function in both the function definition and the range, and we get that. So I will stop there for this question. I guess we have done a good service.